In this video, we will see an example of computing conditional probability. Suppose that 3% of all adults suffer from diabetes and that 32% of all adults are obese. Suppose also that 2% of all adults both are obese and suffer from diabetes. So if we let D denote someone who has diabetes and O denote someone who is obese, probability of someone having a diabetes, according to the information provided, is 3% or 300th. Probability of being obese is 3200th. And probability of both D and O is 200th, 2%. Part A. Find the probability that a randomly chosen adult is obese given that he or she suffers from diabetes. Round your answer to 2 decimal places. So we're looking for the probability of someone being obese knowing that they have diabetes. This is conditional probability, and we use the conditional probability property, which says if you have A and B as two events, to compute probability of A given B, you need to take the intersection of A and B, probability of that, and divide that by the probability of B, the one that is second in the original statement. So, probability of O given D must be probability of O and D, intersection, divided by probability of D itself. In this case, we have those quantities provided. It means that a 200th has to be divided by 300th, and that gives me about 67% or 6700th. Part B, find the probability that a randomly chosen adult who is obese also suffers from diabetes. We want to know what is the probability among people who are obese, also those who suffer from diabetes. So find the probability of someone having diabetes knowing that they are obese. Similarly to the previous example, we follow the rule, and probability will be equal to the probability of intersection of O and D divided by probability of O itself. In this case, 200 divided by 3200 yields 600th.